So from a model standpoint, geometry and materials, this is everything we need to approximate the same example that we worked earlier analytically with the equation for the field of a point charge. And our goal here is to run a computational simulation of this in Maxwell and take a look at what the fields appear to be inside this solution volume and see if we can compare the values that we got for our analytical to our computational. Over here on the left-hand side, though, on the project tree, you'll notice there's a number of different items that might not be so obvious, but these are all connected to the standard workflow that we go through with just about any simulation. So typically, we have models. We covered model over here. We built them up using the geometry features and material assignments. But then there's things called boundaries, excitation. Sometimes we use parameters. We'll talk about mesh a little bit later. All these things follow a natural flow where we set up the problem and we put the appropriate conditions that sort of mimics what's happening in the real world. And then we get to the point where we look at results, and there's different ways of doing that. So if you're able to follow along this successfully, you should get to the point where our results node is going to fill with information that gives us a number that we can compare to the thing that we did in the first part. So the first thing I'm going to do is I want to impose excitations, I believe is going to be the way to do this. So let me choose, if I use my modeler tree, I can see something got selected here. It even tells me down at the bottom one object is selected. It's important to know that it's an object that's selected because I want to apply this boundary to the entire geometry of the object itself. So with that selected, what I can do is in the dead space, or actually I could probably do it on top of this sphere, sphere 1, I will assign an excitation. And there's a number of different ways to do this, but I'm going to use what's called floating. And when I do that, I'll leave all the default names right now. We can always go back and change this, but notice that the parameters are giving me a default value of 0, and there's that capital letter C, which stands for coulombs. So as we did in the analytical calculation in part 1, we set it to 1 coulomb, and I'm going to do the same thing here. So if I choose 1 and OK it, I should now see that over here in the excitations, I get there was a plus sign, which means I can expand that and see a subordinate node called floating. And if I click on that, the properties window should give me information about what that has been assigned to. So very helpful to keep that in mind as we build up more complex models. Now what I'm going to do is make a different excitation on the surfaces of the air box. So keep in mind there should be 6 surfaces as we see them here. If I choose the entire air box, it'll tell me that the object is selected. But what I'm going to do instead is apply a condition to every individual face. It might seem a little bit more cumbersome than grabbing the entire objects, but sometimes there's good reason to do this. I'm going to right click in the dead space and change selection mode from objects to faces. And now when I do that, what happens is that when I choose, if it's a valid face, it'll see it. Notice it over here in the bottom left, it tells me 1 face is selected. If I hold the control button down, I can basically stack up. There's different ways to do this as well, but now I have 3 faces that are selected. And then now I'll choose this, and then I'll choose this, and then that. And now I can see 6 faces are selected. I've got the 6 faces that I want. So all that's happened so far is I've only selected them. Now I want to do an assignment. I'm going to right click, and then if I go to assign excitations, this time I'm going to choose a voltage excitation. And over here on my second monitor, I got this window that came up. Turns out these default values I'm fine with. I want the voltage of the air box on the outside at the very edges to be 0. And it's basically the same as approximating a very tiny little, as if we go out to infinity in the real universe. I'm saying make infinity close by, and that should give us enough of an area to evaluate fields within that same 100 millimeter radius that we did earlier in the analytical part without corrupting the results. And I'll explain that as we get there later on. So for now, I'll just say OK. And notice I've got 2 things now. I've got a floating 1 and I've got a voltage 1. And it tells us where they've been assigned. and it tells us the values as well. So might be helpful for later on. I'm still in face select mode. I'm going to change that by right clicking and changing the select mode back to objects. Notice that I could also use the hotkeys as well to get there. I could have hit capital letter O to get there, but now I'm back in object mode. So with that, what I'm going to do now is finish building out my solution on the project tree. The only thing left to do before we go for a solution should be setting up the analysis node.